I think we should be live. Yeah. Okay, here we go. So, welcome back to another update on the build of the Ant CNC PCB mill. And today I want to talk about essentially like the cable prep that is done in order to prepare for the electronics assembly. It is a separate video. It's the third video in the assembly series made by the Ant team. And essentially, what you do is you prepare a bunch of cables with varying connectors, some of which I've actually never used before, so this is quite somewhat interesting to me. So, the first thing you kind of prepare for this is the motor. This is very easy. This motor that I have is the exact motor that they recommend to buy, but not the one that they have in their video. They have the mystery one, I think, which is the AliExpress version of this exact motor, which is actually from Hobby King. I mean, both are directly from China, so I guess one is Brendan. That's the big difference. I mean, the larger difference for most people is going to be that this you can buy versus the mystery motor you actually cannot buy. Mystery, by the way, is the name of the brand. It's not like, oh, mystery brand, no name motor, as you know, Chinese components tends to be. It's actually called mystery. But yeah, the Hobby King motor is the only version of this motor that is currently available. I've seen some people use different types of motors for this exact purpose as long as they have similar-ish specs. And obviously that's gonna work. At the end of the day, that's a mechanical requirement. As long as you bolt it down properly on the head, everything should be fine. So here we only had to sort of solder the bullet connectors, and I used the bullet connectors and heat shrink that came in with the motor in the very nice little box package. I think it was quite convenient, but maybe a bit extra. So no really big problems on this. Very textbook. Second part that we make is the Z-axis switch, which is probably the simplest cable in this entire step, which I think the team spends a bit way too much time trying to explain how to make. Their cable has to be resized. Honestly, I'm kind of embarrassed right now. I don't know where it is. Um, yes, okay. Well, I was looking for something that was red and white, but this is red and black. So that, I mean, that obviously does the job fine. Uh, Attaching everything properly here to the, I guess you could say, first and middle pins, and then on my multimeter I tested, and obviously the content is made when you click, which is what you want. The other pin, I imagine, is the opposite, so the contact stops when it's being clicked, which can be useful in some applications, but obviously not in this one. Uh, the cable here is going to be quite loose. I did forget to put a heat shrink before soldering everything to the switch. Uh, the cable, the switch the N team has bought already comes pre-heat shrunk, soldered, and everything. Mine actually came as a switch and a cable separate, so I could simply resize the cable, plug it in. Nothing there, very easy. But not everything is that easy, obviously. So we start with one of the first sort of challenges, which is the Z motor connection. So this Z motor is one of the head-on linear motors, which is very similar to the one the N team suggests to buy, but it's actually not the same. It's the only difference is the physical package this comes in with. So like the spindle here is very slightly different from the original. And that spindle that comes with this motor is not this spindle. This I actually 3D printed and slightly modified so that I could fit everything in nicely, and that it came with enough geometric components so it could be directly fit inside. I have yet to test this to know how much it can take. I understand that the thread inside of this probably isn't nearly as precise as it should be, and if it would ever come to this, I can always use the original part that I have very nicely kept and maybe adapt the head the head part itself. I probably wouldn't want to reprint it, considering it already has bearings inside of it that are very hard to take out. But I'll try and figure something out if this doesn't work as well as I want. So the connection here is sort of simple. I use the exact connector um, the end team suggests, and this is important because the team actually, from what I can understand, their motor came with this very specific connector, and mine didn't. It came with a much smaller 6-pin connectors, which is strange because this motor has this is a two pole stepper motor, so it has two different coils and obviously a bunch of like physical poles around it. But it only comes with like two different coils, even though there was a 6-pin connector. This happens from time to time from what I've seen on 3D printers, while they will have 6-pin connectors on one end when plugging it into the stepper motor. Probably because this package is the same between uh, two poles and three poles, or two coils and three coils, and obviously the other end would be 4 pins because, well, there's no other inputs than that. So this is what I did. I replaced the very small connector with this suggested connector, and I didn't have to crimp anything for this, so I simply just all the wires are already installed. I just soldered the wires together. Just looking fine. It could be better. It could be worse. I do like the little heat shrink that I got wrapped around this guy so that to relieve a lot of the strain next to the connector, even though I don't think it's fully necessary. Obviously, there's individual heat shrinks for each wire inside so that they don't shorting each other. Again, multimeter testing makes sure that everything is going fine and everything works well. So the next part is the limit switch connector. Uh, there's two of them. There's oh yeah, okay. One last part about the Z-axis. So this is the Z-axis motor part. Now there's actually the Z-axis connector. The Z-axis connector itself. Actually, I have some concerns to raise with this. So this is like a fairly long cable, which is understandable because the head is going to be moving around the entire area. I heat shrunk the connector so everything inside has individual heat shrinks up to the connector, and then I did this big heat shrink over everything again to relieve strain and to make sure everything is very solid inside of there. Hopefully this ends up being a good idea. And then the rest of the cables, I put a heat shrink in the middle as suggested and connected everything to a DuPont 4-pin. And the way I connected everything, I connected coils, and so that you have like this. So each pair of red and green is a different motor coil. So then there's one motor coil for the two first spins, and then one motor coil for the two last spins. The little green tape on the side here tells me that this side is the same side as this on the other end of the cable. And essentially, the way everything is wired after testing with the multimeter, it is really like one coil with the two first, and then another coil with the two last cables. I didn't respect any kind of order for the coils. I don't think it matters, and from my personal experience and from what's been shown in the video, I don't think they really care about the order of coils as long as they're paired together nicely, which is typically the case for motors like this. Then there's what's next? So limit switch connectors, yes. So these connectors are for the limit switches that are already installed during the bridge and head assembly steps. They're the ones on the little boards where you just plug this 3-pin end in, and then this other end you can place on whatever PCB you want. You can sort of use it however you want. This cable, the way it came in, I had two of them because, well, actually I had four of them. That's a story I may touch upon. Um, but I would have used initially two of them, but they both came with this 3-pin that is used to connect directly to the mounted PCB. So that connector on both ends, and the cable being relatively long, com, com everything with considering that the two cable lengths are quite different. So one is just 10 centimeters or like 15 or well, this is more like 20, I think. Um, but this is fairly short versus this, which is 50, which is longer, but still both of them fit within one cable. And since both ends had this connector, I only had to use one cable, and so I have one remaining, or I should have one remaining if I ordered the right quantity of parts. Because on the website, when I ordered these limit switches, it said one bag contains two pieces. And in my head, two pieces is cable plus a PCB board containing the limit switch. So I said, okay, well, I need two of them, so I'm gonna buy two. But no, two pieces mean two pairs of cable and board. So I end up with four of them. So I have like significant extra, especially cable side, considering this is just one of these cables. So I mean, um, limit switches and their cables don't tend to fail all that often. So I really don't think I'm gonna have too many problems with this, but who knows? Um, then the next is going to be the stepper motors. So these stepper motors, obviously, the cables are trimmed significantly. These are NEMA 11s, by the way. A lot of people say, "Oh, it's so difficult getting NEMA 11s," and so let me get NEMA 17s instead. And yeah, sure, NEMA 17s will most probably do the job just fine. But I did still get NEMA 11s because, well, I mean, with them in my hands right now, I think they're very cute. I don't have a NEMA 17 on hand to compare it with, but it's significantly smaller. And I don't know if this matters all too much, but from what I've seen, motors like this that are thicker tend to have slightly more precision. But that might not be the case for every motor. It probably depends on the construction. Because I've seen some motors from a company called JVL, which are very, very, very thick. I think they're NEMA 17 size, but they're like this thick or something crazy. And all the rotors are sort of rotated at a slight angle from each other, so to give a lot more position. And when you factor in microstepping with this, they could get crazy resolutions out of this. So I don't know if this is going to have an effect on this guy. I doubt. But the package for this seems very reasonable. The price also was reasonable, very comparable to NEMA 17 motors, even if the stock was limited. So when I bought these two motors, these were the last ones in stock. And that was it. After that, that was it. And I mean, it was like 25 Canadian dollars per motor, which is extremely reasonable. So I saw no problem just buying those straight off. Plus, they're smaller, so uh, they don't pull. They're smaller. They're slightly less heavier, so they don't pull as hard on one side of the frame. But really, that doesn't really matter. But I mean, they're there. They're nice. They're cute. They're small, and they were reasonably priced, so I got them. And now we come to the actual cable part of this section. So on the video of the Ant team, they say explicitly that you should plug each coil together in pairs. So the first two cables should be the first coil, and then the second two cables should be the second coil, which is pretty easy to follow because I mean stepper motors are you, I mean, usually it's going to be black green for one coil, and then I mean, for these it's red blue. For the other one, it was red white. But then these are pretty easy to find, and also if you're not sure about the colors, you can just take a multimeter, and a coil is essentially a very long wire that is wound multiple times, and so it has minimal resistances, and ideally it has very very little resistances or resistance. And if you take your multimeter and you measure for continuity between both ends of the coil, you should get a continuous cable. So if you put the continuity probes through both ends through two cables of this and you get a beep, means that they're connected, and so that's one coil. So that's an easy way of figuring that one out. And I still follow the exact color code of the end team. So essentially, for one motor, I have both motors as the exact same cable length, but they don't follow the exact same color code. So one motor has was because these all these connectors have little arrows on them. They can be really hard to see. I don't know if I can actually show this on camera. Maybe it'll focus. I doubt it. I mean, you can kind of see it. It's a bit of a discoloration on one of the pins. And this is very visible on the end team's video. And so for one of the motors, from this arrow, they do a green, black, red, blue. And so I did that for one of the motors. And for the other motor, from the arrow, they do blue, red, black, green. At the end of the day, the same pattern of coils is followed, but the motor cable, the not only the cable order but also the coil order is changed around, which makes me think that for the z-axis motor, even if I don't have the exact same coil order as they have, as long as it's one coil for two cables and then one coil for two other cables, it should be fine. Maybe we're going to have to change the direction of the motor, but that's probably something that's done fairly often. So I don't know. We'll have to see. We'll have to wait for the final build and firmware implementation. Then there's the ESC cable. So the Afro ESC is very well known within the community that the Afro ESC is no longer in stock like anywhere. That's the ESC that's being used by the N team in their videos. And I do remember a lot of people in the robotics team at my university using the Afro ESCs because they're cheap and they're good. But obviously now they're no longer in stock. That's like maybe a year and a half later. And so I just went with some um, Aerial Star 20 amp ESC. Essentially has the same specs, 224S, uh, all this kind of stuff. And this should be a good replacement. This isn't some no-name thing from AliExpress. I actually got this from Hobby King. It is still from China, but I do feel like Hobby King has slightly more reputable brands and products. I mean, they make it feel that way, so it must be true, right? At any rate, this ESC is most likely going to do the job. I've seen multiple people just going with random 20 amp ESCs that have very similar specs, and everything was fine. So my hope is that this goes swimmingly. Now, the one thing about this that has a big difference with the Afro ESC used in the N Team's video is the connector for the power source. They have these 3.5 millimeter male bullet heads on the power side. Mine came with a male XT60 connector. As you can probably guess, unless this ESC and myself are quite large, this is not an XT60 connector. And that is because have I do not have a female XT60 connector handy, and so I had to replace both the male and female the male and female portion with XT30 connectors. I come from a place where many different cables were fitted with XT90 connectors. And as the guy who was responsible for tucking in a lot of the cables, I I saw XT90 connectors as a plague, and XT30 connectors as my savior. Now, I understand that the difference between these types of connectors is how well they conduct, how much they will resist high loads of current, which is extremely important in applications where there's very high currents involved. I've seen batteries that would probably, shock you how big they are, how powerful they can be for fixed wing drones, um, helicopter drones. So not quads, like things that have a single motor that needs to have a ton of force behind it, or speed. more force or speed. Both require this like current. They require power to put together. I don't think this is going to completely melt off an XT30 connector. In fact, in the place I was doing some work at, um, XT90's connector were a massive overkill, as stated by some people. And so eventually stuff switched from XT60s, and I think there were even like switches to XT30s. So I don't feel like this is going to be much of a problem. If it becomes a problem, we'll deal with it later. But for now, it's an XT30 connector that's on there, and hopefully everything's fine. The cables are the same gauge, 16 gauge, um, just silicone wrapped, so the cable's not gonna fail. It's to spec per se, or as much to spec as you can be with a open source sort of DIY project. And yeah, I mean the XT30 connector is sort of matched. I have a battery here which can supply a fairly large amount of current, 3S lipo that has a proper XT60 connector. I mean, this is an XT60 connector. A lot of people probably would have seen it. I consider sort of chopping it off to use it instead, but really that's that's not a good idea. Modifying anything from a battery is always a bad idea, kids. Never do it. And essentially, you see the gauge of these cables versus the gauge of these cables. Like, this is XT60 grade. This, to me, feels like XT30 grade. And if you want XT90 grade, I've seen those types of cables, and they are, I mean, they're even larger. They're one scale up there. So yeah, hopefully everything runs fine for this guy, and that's it for the ESC cable. And so we come to one of the most boring parts, which is the very short servo cable. Really, it's a male to female 3-pin DuPont cable. It couldn't really be used as a servo cable because one of the wires is switched around the female side. So the N team has a one of these brown, orange, and yellow cables. I have one of the black, red, and white ones. They're essentially the same thing. The connectors are very, very, very similar. And it's just a color. So what I had to do is figure out. So if on this end the cable goes A, B, C, then on that end, what does that correspond to in terms of switching the cables around? Turns out it's A, C, B. So it's a very simple change. I had to shorten this cable. It came in at 12 inches. I had to shorten it to 10 centimeters. And also, this male end came with a shroud around it that I actually tore off because that's how their connector looks. I don't know if that's going to be any useful in the hand to have a shroud over this. I don't think so. But if it is, I can always try and print something, some kind of cover for it. And yeah, so uh, to me, if the team is doing something like this, I feel like the shroud is just going to be in the way. And if this doesn't work, then I mean, what am I even watching, right? So I just went with the exact instructions. It's like, okay, you need to follow the instructions by the book, except it's a lot more fun. Then we come to the most interesting part, the part where I mean, talking about following the instructions by the book, this is the complete polar opposite of this. So this is the probe cable, a very interesting way of doing it because the way everything is designed, it uses a headphone, like a very cheap pair of headphones, to get a double strained cable, which can be easily connected by a headphone jack. Now, I do feel like there's something here which is not exact. So, headphone cables have significant amount of insulation to prevent any type of interference. And I mean, there's strain relief as well. but there's a significant amount of insulation to prevent interference. I have no idea how well this is going to work. I don't think this is a very critical part of this, since at the end of the day, this is a cable that needs to go, it essentially creates, whenever the tool will hit the PCB surface, that will create a short that will tell the machine you've touched the PCB. Now mark this as the height of the PCB and go to the next point. So if there was, I mean, if this was connected to the end of something, something like a thermocouple or something like a strain gauge, then I would say yes, proper insulation, proper interference shielding is very, very necessary, because when you're running these two cables, the voltage difference is so small that, I mean, anything will just screw everything up. Because in these very precise sensors, what you're doing is taking an extremely small voltage difference and multiplying by 1,000. And when I say 1,000, I'm barely exaggerating, to try and get any type of reading, visible reading whatsoever. And so in those cases, then getting proper interference shielding on the cables, or just proper like insulation, everything is probably more critical than just having a cable which just goes in and out. Now, the reason I think that this cable is made this way with a headphone jack is because, first of all, if you have a headphone that will work for this, it's easy. And this is very easy to just plug in, take out, plug in, take out. You don't need like a specific connector. You're not going to break anything. This is made to be plugged in and out like a billion times. Now, why exactly a headphone jack? Like design wise, and not just some random other connector with alligator clips? I have elided a few reasons, but like this still bothers me to an extent. Still, I've tried to do something, because all any headphones I had, I did order headphones for this specifically, but I haven't received them yet. And I personally do feel like it's not worth it, because the amount of insulation and all the wrapping around them makes them very hard to actually work with. Headphone cables, that is. And all the headphone cables I had were broken to an extent. So what I ended up doing is harvesting a male jack and seeing how it worked, and sort of working, saying, okay, for one cable, which is the slightly longer one, which is the red alligator clip here, they want only the tip to be connected to there. And so, okay, so this connector on the back, this pad on the back of the connector corresponds to the tip. So route on that cable and only that pad and only that pad through the red cable to this alligator clip. And they said now every other pad on the headphone jack must be connected to the other clips. So what they essentially do is they take all the three other wires coming out of the other headphone and just placing them together. And what I did is I put some heat shrink over that initial cable around the first pad, and then took this green cable. This is frayed wire, by the way. So you cut it, and there's many strands. I split these in three, giving me some decent length, and then connected them equally to all three remaining pads of this connector, which was not the easiest thing to do, but at the end of the day, did a pretty good job. And I'm pretty sure that if it mattered, all the connections are isolated from each other. But at the end of the day, like, no way that matters. Because, I mean, it's just the same, right? But I did a nice job of like doing everything nice and proper. And now uh, this green clip corresponds to the three circular pads, and then this red clip corresponds to only the tip. And I've tested this, and after like a few heat shrinks, I've managed to make a decent holder, like decent connector that offers proper strain release. There's like some other connectors I did, there's multiple layers of heat shrink so that everything is nice and secure. And this, I mean, this works pretty well. So hopefully everything works just as well as I imagine it to. And tomorrow, I think, is the motion systems assembly, which is probably the part I'm waiting for the most. I'm someone who's very interested in anything that actually moves and does motion, and just getting all this belt stuff in and getting those motors to actually move, even though I'm the one like probably going to be moving them initially. That's gonna probably gonna be a lot of fun, and I'll do an update on that when that's finished. So thank you everyone for watching, and hopefully um, you enjoyed this.